Hey grade 10s, alright, let's do the next lesson. We are talking today about our next strategy on how to solve a system, okay? So this time it's called by elimination, as you can see here, and I again have a set of steps to show you how to do that, and again, it might not make a lot of sense, but just let's fill in the blanks, okay? And then as I do the first example, it will make a little bit more sense. The process for solving by elimination includes what we call applying linear transformations, which essentially just means multiplying or dividing an equation by a number. So multiplying every term or dividing every term by some number. And then once we do that, we're going to be able to eliminate a variable, and I'll show you how we do that, okay? But the key thing to keep in mind is that we're always multiplying or dividing by a number and not a variable. Okay, so again, I'm just going to quickly run through the steps. They may not make sense to you, totally fine. When I do the example, I think it's going to click. All right, so again, we're going to start by labeling 1 and 2. The equations, of course, 1 and 2. Then we're going to pick a variable to eliminate, okay, just like last time. Although last time it was to isolate, but we're still going to pick a variable this time, okay? Then we're going to rearrange the equation so that we have the variables organized on one side and the constant on the other side, okay? It's not mandatory, step 3, okay? But it is helpful, and most students find that if they do this, having the constant term on one side and the variables on one side, they find it easier to keep themselves organized and kind of problem solve a little bit more logically. So that's why I put it in the steps, but as you get good at this, you might not want to do that, and that's fine too. Then we're going to multiply each equation by a constant, or as you're going to see soon, possibly just one equation by a constant. And then the point of this is the really important part of this step, is that we're trying to make coefficients for a variable into additive opposites, okay? Additive opposites just means that when you add them together, the result is 0. Okay, so that's like the most important step in this situation, and that's what's going to lead us to success. Okay, once we do that, we're going to stack the two equations together and then add them. And I'll show you how to do that, of course, and then that'll help us to solve for one variable, which in turn we'll be able to use to solve for the other. Okay, so yes, like I'm saying, don't worry if that doesn't make sense. Let's do an example. Okay, let's choose that purple. It's like one of my favorites. And well, let's do this example. Okay. All right, so before I actually do this example, I just want to note that this is the first example from the substitution lesson as well. I just want to show you that you can use either method with the vast majority of these types of questions, and it doesn't really matter. And I wanted to show you that also you'll get the same solution even using different methods. Okay, so heads up on that. All right, so if you look back in your notes, it says that we want to move all the terms to one side and that have variables in them, and then leave the constant on the other side. So we're going to modify equation 1 so that we do exactly that. Okay, so we're going to have 2x and negative y on the left side, and then the constant, negative 5, we're just going to move over. Okay, so when we add 5 to both sides, we get that. Then for equation 2, it's actually already done for us, except that they're backwards, right? So I'm going to just turn the equation around. That doesn't make it any different, right? I'm still saying that x plus y is equal to 4, but I'm just putting it in order so that it makes sense that we have the x's stacked, the y's stacked, and the numbers or the constants stacked. Okay, so that's why I'm doing that. Then once I do that, the next step about the additive opposites becomes relevant, okay? And so actually I'm going to just move these over a little bit, give myself a little bit of room. There we go. Okay, so the question, set of instructions tells us now we want to multiply the equation or equations by a value to create additive opposites. Now, additive opposites is, again, wanting the coefficients to be the same number but opposite signs, so when you add them together, they equal 0. Okay, so we're looking to see, for example, if I had 2x plus negative 2x, that would equal 0, right? Or if I had negative 11y plus 11y, that would equal 0, right? So we're trying to create a situation like that if we don't already have it. Now, the reason I'm saying if we don't already have it is because sometimes we already have it. And in fact, if we take a look here, we're going to see we have a negative y and a positive y. And so if we were to add negative 1y plus 1y together, we would get 0y, which is our intent in this case. So in this case, we actually can just add these two equations together, okay? And so this is the step where it says to stack the equations and then see what happens. So if they are stacked, then it just looks like a long addition, okay? So 5 plus 4 is equal to 9. Negative y plus positive y is equal to 0y, and 2x plus, remember there's like a fake 1 there, 1x, is equal to 3x. Okay, so that would be the result if I added this whole equation to this whole equation. Okay, so then when I get there, I'm going to just be working with this simplified equation. Remember that 0y means nothing. We don't have to include that. It's just plus 0. It doesn't change anything. And then from here, we can divide both sides by 3 to get x is equal to 3. Then what we can do is use this x equals 3 to plug into either equation. Okay, and just like before, plug into either. I can't spell, you guys. It's tough. There we go. Okay. And so I'm going to plug x equals 3 into the second equation. And we're going to see what happens for y. So now instead of x, we have the value for x. And we know that that's 3. And so when we subtract 3 from both sides, we're going to get left with y is 1. So the solution of all points, x, y, that satisfy this solution are the points, just the single point 3, 1. Okay, so there we go. That's our final answer. Now, I know this is a little bit weird, this system, okay, this way to do this, but we're going to do another one, and I hope that's going to make it seem a little bit better to you, okay? This process, I feel people will have questions about, okay? And that's totally fine, nothing to be embarrassed about, like, at all. So please just message me if you realize you're a little bit lost, and I will go over it with you, okay? So again, we're going to start by labeling 1 and 2, and then we are going to do exactly what the first step what we did in the first equation, which was to make sure that all variable terms are on the left and all constant terms are on the right. Okay, so in equation 1, we already have 2x and negative 3y on the correct sides, but I need to move that 6 over to the right, so we're going to end up with equals negative 6. Okay, then for equation 2, we're going to get, so this one, if you need to do this in a couple steps, that's totally fine. Okay, I will do this over here so you can have it copy down if you weren't sure. Okay, so the first thing I'm going to do is I'm going to multiply everything by 2. Okay, so I'm going to do y times 2 is equal to 2 times negative 3 over 2x plus 2 times 17 over 2. Okay, why am I doing that? Good question. It's because I hate fractions. So do you guys? Well, okay, I don't actually hate fractions at all, but I know lots of you guys do. So that's why I'm doing it. And we're going to do that to make a much nicer equation. Okay, so this is like going to be like a giant thought bubble, like very massive. Okay, cool. We get left with negative 2y, positive 2y, pardon me, positive 2y. There's no negative there, my bad. Equals negative 3x. I was looking at the negative 3 and then, I can't write and talk. It's a good time. Okay, so that gives us that, right? 2y is equal to negative 3x plus 17. And then, again, I want to get all the variable terms on the left, so I'm going to move them over, in this case, the negative 3x to get 3x on the left. And then I'm going to leave 2y on the left, and I'm going to leave 17 on the right. Okay, so that's how I get this equation. Okay. Next thing we want to do is want to make additive opposites, okay? So we want to pick a variable to eliminate, okay? So in this case, because we can see we have 2x and 3x, those, when you add them together, do not make 0x. And negative 3y and 2y together, those, again, also do not make 0y, right? There's no natural good luck situation like we had up here where negative 1y and positive 1y, oh dear, that is not what I meant to do. Negative 1y and positive 1y together already just like magically made 0. Not going to get that in every question like here. And so in that case, we're going to need to make that situation. Okay. So what we need to do in this case is pick a variable. It doesn't matter which variable. Okay. Like I can't say that enough times, just like last lesson with the elimination, with substitution, pardon me. It doesn't matter which variable you pick, just pick one, okay? Doesn't matter, we're good. So in this case, I'm gonna pick y, okay? That's, again, you know what? We did y last time. I'm gonna pick x, okay? Just because, doesn't matter. Now you wanna think of what is the, essentially the lowest common multiple, okay, of 2 and 3. And I know that's nobody's favorite in our class. It wasn't our most favorite time in the year, talking about lowest common multiples, but you got to remember how to do it, okay? And so you're trying to make 2 and 3 into the same number, okay? And so the lowest common multiple of 2 and 3 is 6. So that means I'm going to multiply this first equation by 3. And the second equation by 2. And if you're not sure why, I'm just going to go over that quickly. Okay, the reason is because if I multiply 3 by 2, then I'm going to get 6. And if I multiply 2 by 3, then I'm going to get 6. And that's what I'm trying to do. But I do need one of those numbers to be negative. Okay, and again, it doesn't matter here. You can pick either of them to be negative. Okay, so I'm going to pick this top one to be negative. If, for example, okay, there was a situation like this, which we could have picked the y's in this case. So one was already negative and then one was already positive. Then all you need to do is just multiply so that they are equal but opposite. In the case of here, where they don't even have opposite signs, we need to make sure we make one of them negative. Okay, so that makes 1 into negative 6x. Remember, I have to distribute to every term. Okay, plus 9y is equal to 18. Okay, so I just multiplied negative 3 times 2x, negative 6x, negative 3 times negative 3y, positive 9y, negative 3 times negative 6, positive 18. Okay, and then on the bottom equation, equation number 2, we're going to get 6x plus 4y is equal to 34. Okay, then now that we have those equal but opposites, those additive opposites, we're going to add the whole equation together. Okay, so we're going to see very conveniently that negative 6x plus 6x gives us 0x. Okay, 9y plus 4y gives me 13y. And 18 plus 34, quick side note, normally in class with numbers like this, I know that lots of you would prefer to use your calculators. I would give you like numbers that you would do without a calculator, but because we're doing distance learning right now, you can use your calculator. Okay, so just a quick note. Okay, anyways, 18 plus 34, 52. Good. So that gives me 13y is equal to 52. And when I divide both sides by 13, then we're going to get that y is equal to 4. Okay. Now we're going to plug y is equal to 4 into either equation, okay? Now I would always plug into an unmodified equation. That's one thing I realized I didn't say last time, okay? So sometimes when we do like this step, we make arithmetic mistakes or algebra mistakes. And so to make sure that we're plugging into a correct equation, you should always pick like one of the first two, okay? So then we're going to get 2x plus, no, not plus, my bad, minus 3y plus 6 equals 0. So we're going to say we have 2x minus 3 times 4, so minus 12 plus 6 is equal to 0, okay? We know that we can combine 12, negative 12, and 6 to get negative 6. And then we can solve. Oh, I'm running out of space, you guys. Bad. Let's see if I have space on the side. Hang on. Aha, perfect. Okay, so now we have x equals 3, so we can say our solution xy is equal to, what do we have? 3, 4. Voila. Okay. All right, last but not least, we have some word problems. Just kidding, only one word problem here. And we are going to take a look here at trying to solve how much each protein bar and jug of milk cost in this fictitious situation where my two nephews buy a stupid amount of food. I'm joking, obviously this never happened, but we can use it as a word problem. Okay, so Cohen and Brenna go shopping for protein bars and jugs of milk. Okay, first thing we're noticing, we have two different things that we are looking for their cost. So those are going to be our two variables. Okay, then we know information about them. So before I even make the equations, I'm going to assign some variables. Okay, people did forget about that quite often anytime I've taught this, so don't do that. Okay, remember to define your variables. Okay, so let P equal or represent, I guess, protein bars, and let J represent jugs of milk. Okay, you could have absolutely chosen M or B or like literally any variable, X and Y, even if you prefer. It doesn't matter. So what do we see? Cohen buys 20 protein bars. So he buys 20 protein bars and 2 jugs of milk for $63.30. And then Brenna, on the other hand, buys a different number of protein bars, which is 27, and 3 jugs of milk for 86. I don't need the dollar sign because we're just looking at the equations. Sorry. Oh boy, goodness. 86. Okay, it's like I forgot how to write. 70. Okay. So just to go over this, again, you're looking for 2 sets of information. One set is about Cohen, right? And then the other set is about Brenna. So I just made those 2 sets of information into my 2 equations. Okay. Now I'm going to label them 1 and, pardon me, 2. Okay, the next thing we want to look at is are all of our variables on the left and are all of our constants on the right? Yes, thankfully they already are, so we don't have to do any work on that stage. Next, we're going to pick a variable to eliminate. Now, when you pick a variable to eliminate, you want to think about what's easier to make into additive opposites, okay? So, scrolling back, if we looked at this first example, what was easier to make into additive opposites were the ones that already were additive opposites, right? You could have picked to eliminate x, but it would just be harder. Here it would have been pretty much the same, right? 2x and 3x or negative 3y, 2y, it would have been pretty much the same, so we just picked one of them. But if you take a look here, if we have 20p and 27p, do you think I want to make those into the same coefficient? Do you think I want to find the lowest common multiple of 20 and 27? No, I do not. That would be ridiculous. Okay? So because of that, I'm going to find the lowest common multiple of 2 and 3. It's just much easier. Okay? And I'm going to choose orange. All right. I should have left myself a little bit of space, but I forget, as always, to do that. So I'm going to multiply this first equation by 3 and the second equation by 2. Again, that's because 2 times 3 makes 6 and 3 times 2 makes 6. Okay, that's what I'm trying to find out, is how to make those into the same number. Also, a reminder that you can make either of them negative. I'm going to make the first one negative. No, I did that last time. I'm going to make the second one negative. Okay, so we're going to multiply by negative 2. So we get a new equation for 1 that is 60p plus 6j. Yes, you can use your calculator for this number. I'm pulling mine out right now. Okay, I don't expect you to do this in your head if you don't want to. And like I said, I would usually choose in class numbers that you could do on paper. But because we're in distance learning, it's not really a big deal. You get to use your calculators at home. That's fine. Okay. So now I have negative 54p when I multiply negative 2 times 27p, and then I get negative 6j, and then multiplying $86.70 by negative 2 gives me negative 173.40. It's a little bit messy. Classic. Okay, then we're going to add them up, right? We're going to add up these 2 equations. Okay, so, oh my goodness. There we go. Okay, so when we do this, that gives us 6p. Now we know that this equals 0j. I'm just going to stop writing that because it doesn't mean anything, like it doesn't add anything to our work. If you like to write it, you can, but I'm not going to because you don't need it. Okay, and then when I take 189.90 and I subtract 173.40, I'm going to get 1650. Okay, and so if I have 6p is equal to 1650, then when I divide both sides by 6, that gives me p is equal to, I can't write, 275. Okay, then again, Uh-oh, I am like really running out of space here, you guys. I'm gonna have to rewrite that a little bit smaller. Hold on one second. Sorry. If you are wanting to work ahead of me while I redo this little rewriting thing here, you can feel free to. Remember that now we're trying to find the value of j, okay? So plug our value for p into either equation. Doesn't matter which one. Just use an original one, okay? Don't use a modified one. Okay, I have to zoom in a little bit here. Okay, so I'm going to pick the first one just because, okay? So now we know that 20p plus 2j is equal to 6330. Again, you can pick either of them. I don't care, okay? It doesn't matter. As long as you're picking one of the original equations, that will be your easiest bet in solving properly. Okay, so when I multiply 20 and 275 together, I'm going to get 55. Then I'm going to subtract 55 from both sides, and that is going to leave me with 30. Okay. And when I divide both sides by 2, then we're going to see that a jug of milk is $4.15. Okay, so now we just need to answer the question, and because this is not a set of coordinates, right, this is not us looking for a point on a graph, we are looking for a cost, then we're going to answer this in a sentence because it's also a word problem, okay. So we saw that each protein bar costs $2.75 and each jug of milk costs, how much did we say? $4.15. And I want to remind you that we want to always be putting our correct units in our final answer, especially because in a word problem, there's context. Okay, so there we go. That's our answer. There is, again, systems of equations to solve here, and just in case we didn't remember, this is still the same question as all the other worksheets. I still made that typo. It should still be a -2. Okay, so just in case we forgot about that, my apologies. That's what happens when I copy and paste my worksheets. Sometimes I copy and paste my typos. Okay, and I will also post a supplementary elimination worksheet for you as well, and you guys can practice and let me know how it goes. Okay, I'll talk to you soon.